By 2030, NASA plans to begin building a permanent base on the moon. Today, we'll explore what that base could actually look like. But why return to the moon? The Apollo mission ended in 1972. The crew planted flags, gathered rocks, and then left. For more than 50 years, no human returned. But during that time, we made a surprising discovery. The moon wasn't as empty as we once thought. It may contain one of the most valuable resources for human survival. In 2018, scientists confirmed the presence of water ice inside permanently shadowed craters near the moon's south pole. To change that, NASA launched the Artemis program to return humans to the moon, but unlike Apollo, the goal is to stay for weeks instead of days. NASA isn't planning to build just anywhere on the moon. The South Pole is the leading candidate. And for good reason. A permanent base needs power and it needs water. Some high areas receive sunlight for long periods, making them ideal for solar panels. Nearby craters may contain frozen water. Few places on the moon offer both, but building a base starts long before the astronauts arrive. Commercial landers are already practicing soft landings with cargo and instruments. Those cargo runs matter because a crew base needs toilets, filters, cables, and spare pumps before people arrive. So how do astronauts actually get there? Astronauts will leave Earth aboard on Orion. NASA's deep space capsule, once in lunar orbit, Orion docks with a lunar lander. Future missions may also stop at Gateway, a small space station planned to orbit the moon. The lander then begins its descent toward the lunar surface. As the lander descends, its powerful engines will blast lunar dust across the surface. Without an atmosphere, the dust spreads in every direction. Before anyone steps outside, every suit is carefully checked and sealed. Once the dust settles, the real work begins. The first moon base won't look like science fiction. It will look more like a construction site than a futuristic city. Rigid metal modules land first and connect through pressurized tunnels. As the base grows, inflatable habitats can provide more living space. To protect the astronauts from radiation and extreme temperatures, many of these habitats will eventually be covered with lunar soil. It also helps protect the base from extreme swings in temperature. Inside the module, astronauts sleep in narrow sleeping stations. Each astronaut has a small sleeping compartment. There's just enough room for a bed, a few personal items, and a laptop. There are no large windows, no private bathroom. Every part of the habitat is shared. Each module has a different purpose. The largest is the living module, where astronauts eat, work, and spend most of their day. Nearby, another module serves as a laboratory, where scientists study lunar rocks and prepare new experiments. Separate storage modules hold food, spare parts, scientific equipment, and emergency supplies. Every trip outside begins in the airlock, where astronauts put on their spacesuits before stepping onto the lunar surface. Pressurized tunnels connect the entire base, allowing the crew to move safely between each module without exposing themselves to the vacuum outside. Over time, many of these modules could be covered with lunar soil to protect the astronauts from radiation and extreme temperatures. From the outside, the base may look like a series of low mounds rather than a collection of buildings. Building the base is only the beginning. Keeping people alive here is an entirely different challenge. Every drop of water matters. Unlike on Earth, there are no rivers, lakes, or rain. But water isn't only used for drinking. It can also be split into oxygen for astronauts to breathe and hydrogen for rocket fuel. Instead of bringing everything from Earth, astronauts begin using the moon's own resources. Every kilogram produced on the moon is one less kilogram that has to be launched from Earth. That's what turns a temporary camp into something much more permanent. But surviving on the moon means leaving the safety of the habitat. Long before the airlock opens, the crew begins preparing their spacesuits. Preparing a spacesuit can take close to an hour. Every seal, connector, and life support system must be carefully checked before the airlock opens. For short journeys, astronauts may travel on foot. Longer expeditions rely on lunar rovers, allowing the crew to explore much greater distances. Even then, every route is carefully planned. A damaged rover or a failed spacesuit could turn a routine mission into an emergency. Life on the moon quickly settles into a routine. There are no sunrises to wake up to. Only the soft hum of life support systems and the glow of control panels inside the habitat. The day begins with a quick breakfast before the crew reviews the tasks ahead. Some astronauts head outside to inspect equipment, collect samples, or maintain the base. Others remain inside, analyzing lunar rocks, running experiments, or monitoring the station's systems. Exercise is part of every day. Although the moon's gravity is only 1/6 of Earth's muscles and bones still weaken over time without regular training. Outside, every step throws fine lunar dust into the air. The dust clings to boots, tools, and spacesuits, slowly working its way into seals and moving parts. Keeping it out of the habitat becomes a job of its own. By evening, the crew uploads the day's scientific data back to Earth and prepares their equipment for the next mission. Life on the moon leaves very little room for mistakes. A problem that would be minor on Earth can quickly become life-threatening hundreds of thousands of kilometers away. The habitat includes basic medical equipment and enough supplies to treat common injuries and illnesses, but serious emergencies are far more difficult. If someone suffers a major injury, the crew may have to stabilize them and wait for the next opportunity to return to Earth. Powerful solar storms can flood the lunar surface with dangerous radiation, forcing the crew to shelter inside the most heavily protected part of the base until the storm passes. Even tiny space rocks can strike the surface at incredible speeds. The habitats are designed to withstand these impacts, but protection is never taken for granted. Inside the modules, fire may be one of the greatest dangers of all. In a sealed habitat filled with oxygen, even a small fire can spread quickly and threaten every astronaut inside. NASA may be leading the Artemis program, but it won't be building the moon base alone. The European Space Agency, Japan, Canada, and commercial companies are contributing everything from robotic systems and scientific instruments to habitat technology and lunar landers. At the same time, China is developing its own plans for a permanent research station near the lunar South Pole with several international partners. That means the moon could one day host more than one permanent base. By 2030, the first moon base probably won't be finished. Instead, it will be a small outpost built one mission at a time. A handful of connected habitats, a landing pad covered in lunar dust, solar arrays stretching across the surface, robotic machines searching for water beneath the ground, and a small crew learning how to live on another world. It will be cramped, noisy, and surrounded by endless gray dust beneath a sky that never turns blue. It will be humanity's first step toward living beyond Earth.